Our next topic is Fourier sine and cosine transforms. I have already given the formula and notes of Fourier sine and cosine transforms through Google Classroom, and we have done a lots of problem there. Now Fourier sine transform formula is, notation is fs cap of omega. S stands for sine, then fs cap of omega means this is a transformed function. Answer is root of 2 by pi integral 0 to infinity f of x into sine omega x dx. Integration variable is x here, and final answer is a function of omega. The transformed function is a function of omega. Its inverse is, obviously its inverse is f of x. F of x is equal to root of 2 by pi integral 0 to infinity fs cap of omega. That means the Fourier sine transform into sine omega x into d omega. While finding the inverse, the integration variable is d omega. That is the main difference. Similarly, for Fourier cosine transform, fc cap of omega is the notation. C stands for cosine transform. Root of 2 by pi 0 to infinity integral 0 to infinity f of x cos omega x dx, and its inverse is f of x is equal to root of 2 by pi integral 0 to infinity fc cap of omega into cos omega x d omega. So in the inverse, omega is the integration variable, and in the transform, x is the integration variable. That is the main difference. Now let us start with the problem. Find the Fourier cosine transform of f of x is equal to 2 into e raised to minus 3x plus 3 into e raised to minus 2x. We are asked to find out the Fourier cosine transform. So the formula for Fourier cosine transform is, notation is fc cap of omega. Fc cap of omega is equal to root of 2 by pi integral 0 to infinity f of x into cos omega x dx. This is the formula for Fourier cosine transform. Now we are given f of x. F of x is 2 into e raised to minus 3x plus 3 into e raised to minus 2x. But the limit of x is not given. That means we have to choose the limit as integral 0 to infinity, since it is not given. So we have to write f of x is equal to 2 into e raised to minus 3x plus 3 into e raised to minus 2x, where 0 less than x less than infinity. Then, in some cases, the limit of x is given. In that case, you have to apply the given limit here. Here limit is not given, therefore we have to choose the limit as 0 to infinity itself. That is equal to, now we can write root of 2 by pi. Now what is f of x? 2 into integral 0 to infinity f of x is 2 into e raised to minus 3x plus 3 into e raised to minus 2x into cos omega x dx. That is equal to root of 2 by pi into, we can write 2 into integral 0 to infinity e raised to minus 3x into cos omega x dx plus 3 into integral 0 to infinity e raised to minus 2x into cos omega x dx. Then root of 2 by pi is common for both terms. Now we have to integrate this term and this term. We have to integrate these two terms. Let us give a name. This is the first term and this is the second term. In order to evaluate the first term, we must know the formula. Either we must know the formula e raised to ax into cos bx formula, integral e raised to ax into cos bx. Similarly for second term also. But here the limit is 0 to infinity, and there is a shortcut method to evaluate this integral. Since the limit is from 0 to infinity and Integrand is the product of an exponential term and a cosine function. We can compare the integrand using Laplace transform. So what is Laplace transform? We know that L of f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. Now what is Laplace transform of cos omega t? Laplace transform of cos omega t is equal to integral 0 to infinity e raised to minus st into cos omega t. F of t is cos omega t dt. And we have a formula for that. What is Laplace transform of cos omega t? Cos omega t has the formula s divided by s square plus omega square. This is from 4th module. We have already studied Laplace transform and Laplace transform of cos omega t, sin omega t, e raised to t, etc. Here we use the formula Laplace transform of cos omega t is equal to s by s square plus omega square. So using this result, we can integrate the first and second terms. The only change is here limit is 0 to infinity. This is also 0 to infinity. E raised to minus st f of t dt. So in the place of in the place of t, here the variable is x. So e raised to minus st, it is e raised to minus 3x. Cos omega t, it is cos omega x dx. T, here it is x. So this is an integration with respect to x and this is an integration with respect to t. Since the limit is from 0 to infinity, final answer will be the same. And one more change is there. This is the general formula. In the general formula, final answer is a function of s. But here we have a value for s. What is the value for s here? For the first case, what is the value of s? S is equal to 3. That means the first integral can be written as Laplace transform of cos omega x. Laplace transform of cos omega x is same as Laplace transform of cos omega t. This is actually s divided by s square plus omega square. We can substitute the value of s, that is 3 divided by 3 square is 9 plus omega square. So we got the value of the first integral. First integral is equal to Laplace transform of cos omega t and the answer is 3 divided by 9 plus omega square. Similarly for the second case, what is s? This is e raised to minus st, this is e raised to minus 2x. Instead of t, the function is x. So instead of s, what is the value of s? S equal to 2. So we can write Laplace transform of cos omega x again, that is equal to the second integral. Second integral value is equal to s divided by s square plus omega square. S is 2 divided by 2 square, 4 plus omega square. So we can find the values of these two integrals without integration, that is by the comparison of, using the comparison of Laplace transform. So the value of the first integral is 3 by 9 plus omega square. Value of the second integral is 2 divided by 4 plus omega square. Now we can substitute the values of the first integral and second integral. That means Fourier cosine transform of omega is equal to root of 2 by pi, then 2 into value of the first integral is 3 divided by 9 plus omega square plus second term 3 into value of the second integral value is equal to 2 divided by 4 plus omega square. That is fc cap of omega Fourier cosine transform is equal to 3 into 6. 6 is common term in the numerator for both terms. 6 into root of 2 by pi into 1 divided by 9 plus omega square plus 1 divided by 4 plus omega square. This is the Fourier cosine transform of the given function. And there is a homework for you. Find the Fourier sine transform of the given function. Then what is the function? F of x is equal to 2 into e raised to minus 3x plus 3 into e raised to minus 2x. Find the Fourier sine transform of this function. Find out the answer, find the Fourier sine transform and post the answer in Google Classroom. Okay, thank you.